Hello students, welcome to EPG Pathshala. I am Dr. Shaukat Mir from Ahmedabad University, Delhi. Today we are going to talk on module Spectroscopic Analysis of Natural Products under the paper Pharmaceutical and Biological Analysis. After completing this module, we should be able to understand the need and importance of evaluation of natural products, different parameters for the spectroscopic analysis, and we will be also understanding the recent advances and the future prospects of spectroscopic analysis. Let's get started with the definition of drug evaluation. It can be defined as the determination of identity, quality, and efficacy of a drug. So, identity means the identification of the source or the biological source of the drug. Quality, as you understand, it is a measure of the content and purity, that how much of a substance is present inside this drug and how much pure is it and what content is there. And the last of all, the efficacy is the determination of the intended use of the drug. So these drug evaluations have their own importance. So they can be used in establishing the quality and purity of drugs. The drug evaluation can also be used for standardization of therapeutic regimes. So we understand that these drugs, they are to be used for the treatment of disease. So how much drugs and when to, what is the recurrence and what is the dose and other things related to drug therapy. So that needs to be decided on the basis of these drug evaluation experiments. Identification of deterioration due to faulty preparation, storage, and transport can also be ascertained with the help of drug evaluation. So it also helps us in reporting the adulteration and substitution as a result of carelessness, ignorance, or fraud on the part of the suppliers or the manufacturers. And the last of all, drug evaluation of crude drugs helps us to determine biochemical variations found in the drugs. This slide shows different parameters for the evaluation of herbal products and natural products. So here we can see that we have botanical methods, organoleptic methods, biological or chemical methods that can be used for the evaluation of herbal drugs. In this module, we are going to discuss spectroscopic analysis, which is the part of physical evaluation. So we have discussed other parameters for physical evaluation somewhere else as a part of another module, but here this module is specific for spectroscopic analysis. So now let us discuss spectroscopic analysis. So as we understand that spectroscopy is at the center of spectroscopic analysis, so it is based on the interaction of natural products or any substance with the parts of the electromagnetic spectrum. We understand that the electromagnetic spectrum, it extends from cosmic rays to the radio waves. So the study of interaction of natural products with the parts of the spectrum, it is the basis of spectroscopic analysis. It is also synonymously known as spectrophotometric analysis or spectrophotometric evaluation. Spectrophotometric or spectroscopic evaluation can be based on any of the following. It can be based on UV visible spectroscopy, IR spectroscopy, fluorescence spectroscopy, X-ray diffraction, or even nuclear magnetic resonance spectroscopy, and last but not the least, mass spectroscopy, which is known as tandem mass spectroscopy. So now let's understand spectroscopy is. So this stretch at the top shows the electromagnetic spectrum. So we can see that it extends from cosmic rays to microwave radio. So with the increasing wavelength and decreasing frequency. So when we use the part of this electromagnetic spectrum for the evaluation of substances, natural products and herbal natural products, so we call it as spectroscopic evaluation. So spectroscopy is the study of interaction of electromagnetic radiation with a substance. So a substance absorbs energy or emits energy in the form of discrete amounts called quanta. The absorbance of a compound at a particular wavelength increases with an increasing number of molecules undergoing transition. So we can see in this, we have this white portion which is visible region. Left to this we have ultraviolet region. The right side we have near IR and IR regions. So we can use UV, visible or IR region as well as X-ray diffraction techniques for studying the quality of substances, so which come under spectroscopic analysis. So spectroscopic analysis or evaluation can be done for a range of substances, including these natural herbal medicinal products. So the electromagnetic variations used in spectroscopic analysis can be classified into the regions as shown below. Ultraviolet region, which starts from 200 and ends at 400 nanometers. Visible region, it stretches from 400 to 800 nanometers. Infrared stretches from 400 to 3000 nanometers, while as infrared, it stretches from 3 to 40 micrometers. The measurements in spectroscopy can be done by any of those methods, by any of those parameters like absorbance, transmittance, optical density, or extinction measurements. So when a light of specific wavelength is passed through a solution of a substance, its response to the incident light can be represented by absorbance or transmittance or optical density. Absorbance is the measure of how much content of light gets absorbed by a substance. So more reliable or more accurate measurement is for transmittance, which is the ratio of the light that gets transmitted with the sample to the measure of light that gets transmitted without the sample. So transmittance, that is depicted by T, is equal to 1 upon 110, while as absorbance it is the reciprocal of transmittance. A more accurate one is the representation of this absorbance by optical density, which is decimal optical density. So E is equal to log to the base of 10 I0 upon I. Optical density is proportional to the number of absorbing units in the light path. So fairly dilute solutions follow this proposition, and this is called Bayes' law. The other method for the measurement of the for the evaluation of spectroscopic data is by extinction measurements. So here we can see there is a diagram which shows a plot between absorbance and concentration. So as there is increase in the concentration, there is a relative increase in absorbance. So in dilute solutions, there is a linear increase, so which is governed by Bayes' law, so and is represented by this straight line. So an unknown sample, a sample of unknown composition or strength, can be determined if we have this plot, which is known as standard plot. So we take dilutions represented by standard 1, 2, 3 and 4 on the plot. So these are known concentrations. For these known concentrations, we record their absorbance, and finally we subject the sample of unknown concentration to the same recording of measurement at the same wavelength, which is preferably a lambda max. So the absorbance that we get can be extrapolated to know the concentration from this graph. Now coming to the absorption spectrum. The absorption spectrum of a substance, as shown on lower right hand side, is a set of values for a substance at a unit concentration when the thickness of the layer traversed by light is 1 centimeter. So this is a UV spectrum for a substance. So we can see those peaks, bands. So this is a specific pattern. So all substances, they follow a specific pattern in absorption spectra. Now we should understand that the analysis with spectroscopic methods may need a preliminary sample preparation step. It can be a simple purification step so that the active constituents they are separated, or the substance that is to be identified and analyzed, that needs to be separated. So that may need a preliminary sample preparation step. So that is why the current focus is on using spectroscopic methods in conjunction with chromatographic methods. So it is being increasingly used in the analysis of natural products. So first we separate these compounds, from these matrix using chromatographic methods, and then we study them by spectroscopic means. Absorption spectra such as UV and IR are very useful techniques for the spectroscopic analysis. They are otherwise also used in the identification and determination of structure, purity, and analysis of compounds. Absorption in UV visible region, IR or near IR regions of the electromagnetic spectrum is the basis of analysis of several natural products. Several of those pharmacopoeias that are followed in the world, they prescribe or they include several of those assay methods which are either of the UV visible nature or of IR region or near IR region. They also provide these absorption spectra, they also provide key information about the structure of natural products. So UV analysis, we understand that in UV analysis, the energy that is used for recording the UV spectra, UV absorption, they are strong enough to bring about electronic changes. So this means that when an UV light is put on a sample, so there is excitation. So the electrons, they travel from lower energy level, they go to the higher energy level. So they are also associated with smaller changes related to vibrational and rotational changes. So this is the reason in a UV analysis, when you record a UV spectrum, you get a banded spectrum rather than a line spectrum. So UV is the most sensitive of all these spectroscopic techniques. It is a simple technique, and since several of those advancements have been made, particularly with respect to the introduction of derivative spectroscopy, the sensitivity of these UV spectrophotometers that has improved tremendously, and so that have also increased the utilization of UV spectrum or spectroscopy in the analysis of trace analysis. All major pharmacopoeias, as I have told you earlier, that UV is the absorption spectrum is the basis of several of those active pharmaceutical ingredients or natural products. Now let's go to the applications of this UV visible evaluation for the analysis of alkaloids. So the first example is the estimation of reserpine in Rauwolfia serpentina, roots, rhizomes, and extracts. The diagram for the chemical structure of reserpine is given here. So in the extracts and in the samples of Rauwolfia, the reserpine can be estimated by measurement of optical density at 268 nanometers. Another determination for very significant anti-tumor compounds, vincristine and vinblastine, that are found in periwinkle called Catharanthus roseus. The aerial parts of this plant contain this alkaloid. So these alkaloids can also be examined or determined by carrying out UV determinations at 267 and 297 nanometers. The estimation of morphine in Papaver somniferum and in opium can be done by measurement of optical density at 286 nanometers. So as we understand that morphine, it still remains a gold standard for several of those analgesics that are either natural or synthetic. So a very significant compound can also be estimated by UV evaluation. The example 4 is that of tuberculin estimation, which is neuromuscular blocking agent. The analysis of this compound can be carried out at 289 nanometers. So mind you that we need to get some of those interfering substances. We need to remove them before these tests can be used for the estimation of these alkaloids. Now we move on to the assay of alkaloidal mixtures. So earlier we have discussed the assay of some of those individual alkaloids. So it is also useful for the determination of alkaloidal mixtures found in same plant or in different plants. For example, in example 1, we see that 2-point UV spectrophotometric assay is available for the determination of strychnine and brucine, which are the alkaloids present in Nux vomica, and they are also present in its preparations. So they can be accurately measured by a two-way UV spectroscopic assay by measurement of optical density at 262 and 300 nanometers. This method is official in British Pharmacopoeia. The other good example for the use of UV spectroscopy, the analysis of alkaloid mixtures, is that of method prescribed by European Pharmacopoeia for the estimation of quinine-like and cinchonine-like alkaloids in cinchona bark. So it is a very useful assay method which takes into account extinction measurements that are made at 316 and 348 nanometers. Now let's move to the analysis of oils using UV spectrophotometer. So cassia oil, the alkaloidal content of this oil can be estimated using UV spectroscopy when the optical density is measured at 286 nanometers. So the measure alkaloidal content, aldehyde content in cassia oil is cinnamaldehyde besides others. In the same way, bergaptin, which is a constituent of bergamot oil, can be determined by carrying out UV spectroscopic determinations at 313 nanometers. UV spectrophotometry, vitamin A content in cod liver oil, which is, as you can see in this picture, it has conjugated double bonds. So it can be done by recording optical density at 328 nanometers. So vitamin content in cod liver oil and other products which contain cod liver oil can be determined effectively by using UV spectrophotometer. USP prescribes a UV absorbance test for the absence of foreign oils in lemon and orange oils. In the same way, British Pharmacopoeia also prescribes the use of extinction limits for the analysis of castor oil at 268 and 70 nanometers. These are some of those assays for other constituents which are carried out by UV spectrometry. Number 1 is cardiac glycosides containing a butanolide side chain that are present in digitalis can be assayed by recording the optical density at 217 nanometers. Cosinoids, they are a class of compounds which are present in quassia wood. They are quite specific in their occurrence in quassia wood. So the quassia wood as well as extracts can be subjected to cosinoid determination by UV spectro method at 254 nanometers. Third example is that of capsaicin, which is present in capsicum and in several of those topical preparations that use capsicum or capsaicin. So in these preparations and in products, the capsaicin can be effectively assessed by UV spectroscopic measurements at 248 and 295 nanometers. The last example is that of vanillin, which is present in several of those aromatic plants and in flavored preparations. So in these preparations, vanillin content can be estimated fairly accurately by UV assay by recording optical density at 301 nanometers. So as we have seen in UV spectrophotometry metric analysis, that a UV method, it works very good once you don't have these interfering substances along with in the matrix of the analyte. But this is not the situation which is most often met in natural products. So when you have interfering substances, or when the pure substances are not available, so what are you going to do? So visible analysis or colorimetric analysis is the way forward. So here what we do, that the substance to be analyzed, it is treated with some chemicals which result in the formation of color reactions, which result in the formation of a color, and that color, visible color, it is measured, or the absorbance is measured, which is the basis of colorimetric analysis. When pure solutions are not available for analysis, so this is particularly useful for these types of analysis. It can be carried out with simple colorimeter, or even we have the modern UV, they are usually UV visible spectrophotometers. So they can record both UV spectrum as well as visible spectrophotometry, while as we have separate visible colorimeters, which are known as colorimeters. The instrument consists of these colorimeters or UV visible colorimeter spectrometer. It consists of a light source, the filters that are put inside, that are put in its way to filter out one specific wavelength, and the photoelectric cell as a recorder. The transmitted light which moves through the sample is recorded, and the composition of the test sample is determined by reference to a standard plot. Now let's go to the examples related to the colorimetric assays. Again, we have several of those alkaloids estimated by visible or colorimetric assays. So the estimation of reserpine in Rauwolfia serpentina roots and extracts can be undertaken after treatment with sodium nitrite in dilute acid. So it gives a color reaction, and which can be followed by optical density measurements at 390 nanometers. Second one is the determination of morphine in papaver and opium. So that can be carried out after nitroso reaction of morphine, and the determination is carried out at 442 nanometers. Total alkaloids in aggregate can be estimated either by use of paradimethylaminobenzyaldehyde reagent and recording of absorbance at 550 nanometers, or by the use of vanillin in higher concentrated HCl at 532 nanometers. We can estimate tropane alkaloids in solanaceous plants following Vitali-Morin reaction. The measurements can be made at 555 nanometers. So in all these cases, you can see that there is a need for the treatment with reagents which give color reactions, and those colors, they are estimated in visible region. We have now assay of glycosides. The basis of these assays are colorimetric assays, colorimetric region, visible region. The assay of cyanogenetic glycosides, as in almond, can be carried out by cyanide determination at 630 nanometers. The estimation of anthraquinones in senna leaf in the form of cyanosides can be undertaken after treatment with alkali, followed by measurement of optical density at 500 nanometers. So in case of aloe, cascara and rhubarb, the anthraquinones can be estimated by measurement of optical density at 515 nanometers following the same treatment. Cardioactive glycosides in digitalis can be estimated by any of the methods given at the base. Number A is you use Killer-Kiliani reaction and estimate it, and you record the absorbance at 590 nanometers, or you can follow meta-dinitrobenzene treatment and record optical density at 620 nanometers. The first one is the specific reaction for digitoxos, while the second one is due to the presence of lactone ring. There are several other compounds that can be estimated by colorimetric assays that use visible region of the electromagnetic spectrum. The first one is BP prescribes colorimetric method assay for the estimation of tannins at 750 nanometers. So this can be done after treatment with phosphomolybdic acid and sodium carbonate. Estimation of menthol in peppermint or mint oil by the use of dimethylaminobenzylaldehyde reagent, followed by measurement optical density using green filters. So this can be done. This method can be used for the estimation of menthol. And capsaicin in capsicum can also be effectively assessed by treatment of sample with molybdic acid and NaOH and recording absorbance at 730 nanometers, or by reaction with diazobenzene sulfonic acid in sodium carbonate at 505 nanometers. Another important analysis is on the basis of IR and near IR. So as I told you, like in case of UV, the incident light is of the energy that brings about electronic transitions. But in IR, low energy light wavelengths, they are made incident, they are made to fall on the sample. These energies, they are only sufficient to bring about small vibrational and rotational changes in the molecule. So these changes are associated, these are characteristic changes that take place within molecules. The IR spectrum and the absorption of these small wavelengths, these wavelengths result in IR or near IR spectrum. The analysis of IR near IR spectra is the basis of this analysis. The IR spectrum shows line spectrum. It is in the form of line spectrum in the fingerprint region, which is the near IR region, while as it gives a banded spectrum, band form of spectrum in the functional group region, so which extends from 12 to 40 micrometers. The process for the recording of IR spectrum is that we make a solution in CCl4 or carbon which is known as carbon tetrachloride. Or it can also be made into a mull with Nujol oil, or even solid samples can also be put in the place in the path of an IR light, so that its IR spectrum is recorded. In case of powder sample, a disc can be prepared by molding it into a flat disc, or the KBR is used, dry KBR and hydrous KBR is used for preparing this disc, and the sample is analyzed for recording its IR spectra. This slide shows the diagram of an FTIR spectrophotometer, a very significant analytical tool that is used for the analysis of herbal drugs and products. So the Fourier transform IR has increased the sensitivity of classical IR, the older versions of IR, several folds, and it has also made it more rapid in its measurements. The British Pharmacopoeia 1980 volume 3 consists of a compilation of IR spectra for many medicinal products, including synthetic as well as natural products. So this compilation is very, very significant with respect to working with these substances. So this is a depository which every student should visit and check, so that any sample that you have for your research purposes, so that can be identified by comparing the IR that we get for our samples with these spectra given in volume 3 British Pharmacopoeia 1980. IR and near IR based assays. This slide gives a list of such experiments which can be done with IR or near IR region. The first one is quantitative estimation of quinine and strychnine. Mixtures can be achieved by comparing absorption maxima at 6.2 and 6.06 micrometers. So students should take care that some of these values can be changed into wave numbers, which are unit for which is centimeter inverse. The next assay is for the evaluation of mixture of steroidal sapogenins in herbal plants using IR spectroscopy. So the measurements of optical density are made at 11.11 and 10.85 micrometers. So with this method, there is a possibility of determination of epimeric sapogenins, 25 alpha and 25 beta sapogenins. The next example listed at number 3 is the determination of adulteration of cassia oil with leaf or twig oil can be detected by the estimation orthomethoxycinnamaldehyde at 7.18 and 7.62 micrometers. So IR, this assay is also very significant for the determination of moisture as shown in figure at 4. Water content in expensive and sensitive herbal products can be determined fairly specifically using IR at 1.9 micrometers. NIR IR spectroscopy has been successfully applied for the natural product composition analysis, product quality assessment, and in production control. So it can provide us global signatures for the composition of herbal products as well as all natural products. With the application of chemometric techniques, the composition of these natural products can be related to the geographical location or even to the genetic makeup. Fluorescence analysis is another type of spectroscopic analysis which is very useful, particularly with respect to natural products. So here, some of those substances, when they are irradiated with UV light, they emit a longer wavelength, or they remain colored for some time. So this is known as fluorescence. The process is called fluorescence. And the process of recording that emitted light is known as fluorescence analysis. The fluorescence spectrum is characteristic of a substance which exhibits the phenomena of fluorescence. The emitted light ceases or it stops when the exciting light, which usually is a UV light, is removed. A fluorimeter is an instrument which is used for recording this fluorescence phenomenon. So it consists of a strong UV light source. As I told you that this process starts with the strong UV light. So a tungsten arc or a mercury lamp can be used as a source of UV light. Then we have filters to single out some of those short UV waves. And then a photoelectric cell is used to measure the intensity of the emitted fluorescent light. So we also have these fluorimeters in the form of long and short wavelength handheld lamps, so which can be used on solid samples, liquid sample, as well as on the chromatograms. It can be used for both qualitative as well as quantitative analysis in solid, liquid, or powder samples. The use of fluorescence analysis for the analysis of natural products. The example can be, first one is quinine can be conveniently assayed by the measurement of blue fluorescence produced by the irradiation of the alkaloid in dilute HCl at 450 nanometers. In the same way, senna and hydratis, they can be estimated by fluorescence analysis following Born-Traeger reaction or oxidizing the hydratis extract with nitric acid. The mixture of cardiac glycosides in digitalis can be estimated after the separation on chromatographic plates and final determination done on fluorimeter. Reserpine in Rauwolfia can be estimated by the measurement of green fluorescence produced when reserpine is oxidized with H2O2 in acetic acid. The fluorescence pattern of powder sample is also an important method of analysis of herbal products. The powders, they are treated with different reagents like sodium hydroxide, ferric chloride, etc. And the fluorescence is recorded following UV light exposure at 254 and 366 nanometers. So such estimations have been used for the detection of ergot in wheat flour, differentiation of rheum officinalis or emodi, which give brown fluorescence, from that of rheum reponticum, which gives yellow color, as well as the detection of repontic rhubarb. With respect to oils, fats and waxes, generally speaking, fixed oils and fats, they fluoresce least, waxes more strongly, whereas mineral oils, they are most strongly fluorescing substances. Chromatographic methods. Fluorescence can be also used in chromatographic methods. So it can be used for the determination or the localization or visualization of compounds on paper chromatogram or a thin layer chromatogram. So as you can see on the left hand side, we have TLC plate showing bright spots. This is fluorescence when the slide is exposed to 366 nanometers UV. While as on the right hand side we have this green plate, it is actually the opposite of fluorescence, which is known as fluorescence quenching. The material which is used for the preparation of this plate, it contains an fluorescent inorganic substance which fluoresces at 254, and the compounds which are not fluorescing, they are visible as dark spots. These are some of those recent advances for the use of spectroscopy in the evaluation of herbal drugs. So this thing is coming very nicely, which is NMR spectroscopy. Here in the lower panel you can see that there is a stretch of proton NMR. So for the extracts, the proton NMR, they are recorded and they are slated one above the other, and the regions for secondary metabolites, primary metabolites, sugars or amino acids, they are marked. So profile of these extracts, they are compared, and the differences or the similarities, they are noted. So this is the use of NMR spectroscopy for the metabolomic studies. This is a recent advance in the use of spectroscopy, but it has to go a long way before it can be used for large scale. The another recent advance which uses mass spectroscopy is tandem mass spectroscopy. As we understand that mass instrument consists of an ion source, a mass analyzer and a detector. In tandem mass, two or more mass spectrometers, they are aligned in series. So the simultaneous use of these mass makes it possible to target particular compounds in complex mixtures, extracts of plant materials, and it is particularly useful. It has been used recently for the analysis of cocaine in plant materials, pyrrolizidine in cinaccio, aflatoxin in peanuts, and the analysis of steroids and antibiotics. So students, let us now summarize what we have learned from this module. Absorption in the UV visible IR or near IR regions of electromagnetic spectrum is the basis of analysis of spectroscopic analysis of several of those natural products. They also provide key information about the structure of natural products. So they can be used for the determination of structure as well as they are for the detection in some of those matrices. UV is the most sensitive spectroscopic method that is used for their analysis, and over a period of time this has improved several folds. The technique has improved, and that has made this UV spectroscopy even suitable for trace analysis. In case of IR, Fourier transform IR spectroscopy has far more greater sensitivity and far more rapid speed of measurements. Another thing that has particularly affected the way we analyze natural products or the spectroscopic evaluation of natural products is concerned. So that is near IR spectroscopy. So with the help of near IR spectroscopy, the fingerprints can be developed which can be used along with the help of these chemometric techniques. They can be used to know the compositional characteristics and variations in plants or plant products. NMR and tandem mass spectroscopy is used nowadays in the analysis, in the natural product analysis vis-a-vis metabolomic studies, and they hold a good future. Thank you.